Hi everyone, this is the video that accompanies my final graphs worksheet, which is worksheet 11, and it's all about graph transformations. So in this video we're going to do a recap of what a function is. We're going to then look at translations, that is graph translations, and what we need to do to functions to translate their graph. And by translate I mean move up, move down, move the graph left, move the graph right. This is going to be opposite to how you're seeing it. And then finally we're going to look at reflections. What does reflecting a function mean and how do we do it? As usual, the image of the worksheet as well as the answer sheet can be found on my Instagram page. I'll leave a link to this in the description box below. If you have any feedback at all, please let me know in the comments below or over on my Instagram page. I'm always trying to improve. And yes, I hope you like the video and I'll see you later. Right, this is the worksheet. I've touched on functions in other worksheets, but I thought it wouldn't be a bad thing to go over them once more here to show you that there's nothing fancy about the notation and you shouldn't be put off by these kind of symbols. So when you see this expression, it is telling you that y is equal to some function of x, i.e. you have a y on this side of the equals sign and a bunch of x terms and constants on this side. For instance, here in this example, I could say to you y is equal to f of x, but actually f of x is equal to x squared minus 4. Similarly here, I could also say y is equal to f of z, where f of z is sine z. Now you might ask then, well, why even bother with this f of x or f of z? Why don't you just write y is equal to x squared minus 4 and just not bother with this? Well, this expression is often used when we don't actually know what f of x is. So we know it's some function of x, but we don't know what it is. So it's a good way to write something we don't actually know about. Additionally, we can also write this expression when we want to generalize. So we don't want to restrict ourselves to just a function that is x squared minus 4. We might want to mean all functions of x, like any function. So that's why you'll see this. Either we don't know f of x or we're just generalizing. As it turns out in this worksheet, the reason why I use f of x is because I want to generalize, because I'm going to talk about something that affects all functions no matter what they are. Okay, let's look at the first proper section, which is translations. Right, to transform a graph is referring to the act of changing how a function's graph looks on a chart. Types of transformations include moving a graph up, moving it down, moving it left, moving it right. These are called translations. Other types of transformations include reflecting a graph or rotating it, magnifying it, minimizing it, just messing about with it basically. So in this section, we're going to look at translating graphs. Like I said, these are a type of graph transformation that move a graph up, down, left or right. So let's look at the up and down translations first. So if you had a function y equals f of x, right, this guy here, then if you want to move this function's graph upwards, i.e. in the positive y direction, then what you have to do is you have to add some positive number, let's call this positive number a, to your function. And this is what I mean. Y is equal to f of x plus a. Adding any positive number to a function will shift its graph upwards vertically. So if this was our original graph here in reddy pink, then what this transformation would do is it would move this whole graph upwards. Here we go. This is showing it. So by doing this, your graph will move up by a in the positive y direction. When this function shifted upwards, this point here moves up here. The x coordinate stays the same as the original coordinate, but the y coordinate becomes f of x plus a. Okay, what about the other way around? What if you want to translate a graph and move it downwards? So this direction in the negative y-axis direction. Well, hopefully you've already intuitively realised what we must do. If you have a function y equals f of x and you want to move its graph down, then what you have to do is you have to subtract some positive number, say a, from your function here. That's what I've just said. Y equals f of x minus a. You're subtracting this positive a. And by doing this, your graph will move downwards. Here we go in blue. When we transform y equals f of x by moving it down by a, then this point here moves down by a as well. And so its coordinate goes from this to this. If this is totally confusing yet, then don't worry, because I have an example. Now this section, this worksheet is quite chunky. There's a lot to it. So I've actually put a worked example on an additional page. So let's just head to that and let's go through some examples of these, some examples of taking a function and transforming it so that it moves up a certain number and down a certain number. Okay, so here we have our function. Y is equal to f of x, where f of x is equal to x plus 2. If we want to translate this function's graph by moving it up by 2, then as we've just learned, we need to add 2 to the function. So let's look at how this is done. So our translated function I'm going to call y subscript up, and it is equal to f of x plus 2. Do you remember what we saw here? We've got the f of x plus a. Well, we know we're wanting to move up by 2, so we've got f of x plus 2. So what does this equal? Well, we know f of x, it's our original function and it's x plus 2. So this becomes x plus 2 plus 2, which simplifies to x plus 4. So y subscript up is equal to x plus 4. So let's plot this function. Here, given by this red line, is the original function. This is y is equal to x plus 2. It's this function up here. And in orange is this function in red, but translated by 2 in the positive y-axis direction. It is this function here, that is this line. Therefore, hopefully you can see how a translation happens algebraically here and also how it looks graphically here. This line has been shifted up 2, and this line is described by this function here, which is actually the original function, but with 2 added to it. Also note what has happened to this point on the original graph. It has moved up here. So it's gone from having this coordinate -1 and 1 to having the coordinate -1, 3, i.e. the x coordinate has stayed the same, -1. However, the y coordinate has increased by 2, and that is what we have shifted our function up by. We shifted it upwards by 2. What about an example of translating a graph down in the negative y direction? So again, our original function is still the same. Y is equal to x plus 2. However, this time we want to translate this function's graph by moving it down by 3. So to do this, we need to subtract 3 from the function. So let's look into this. Our translated function is given by y subscript down and is equal to f of x minus 3. Remember, this f of x is from our original function, so this becomes x plus 2 minus 3, which then reduces to x minus 1. So we have y subscript down is equal to x minus 1. So again, going back to our graph of our original function in red, and in blue is this function, but translated 3 in the negative y-axis direction. Therefore, hopefully you can see how a translation happens algebraically over here and graphically here. Again, let's also note what has happened to the point. This point on the original graph has moved down here. It originally had this coordinate -1, 1. It now has the coordinate -1, -2, i.e. the x-coordinate has stayed the same, but the y-coordinate has decreased by 3, which is what we subtracted from the original function. Right, that's translations that move a graph up and down. What about translations that move a graph left and right? If you have a function y equals f of x and you want it to move its graph to the left, i.e. along the x-axis in the negative direction, you have to replace all the values of x in your function with x plus a. Here, this describes what I've just said. By replacing all values of x in your function with x plus a, you're moving your graph to the left by a in the negative x-axis direction. Here we have it drawn out. Looking at this point here, we have the coordinate x and f of x. Remember, this is actually equal to y. When we transform the function y is equal to f of x by moving it left by a, every point that the function passes through moves left by a. So this original point here with this coordinate shifts along here to this space here, which has this coordinate, x minus a, comma, f of x. Okay, so what about the other way around? What if we want to translate a graph and move it to the right? Again, I hope you can see what is coming. If you have a function, y equals f of x, and you want to move its graph right, i.e. along the x-axis in the positive direction, you have to replace all values of x in your function with x minus a. And here's that written. So, by replacing all values of x in your function with x minus a, you're moving your graph to the right by a in the positive x-axis direction. And that can be seen by this blue line. Again, we like to look at points. This is the original point and its coordinate. If we shift our graph to the right by a, this point moves to here and its coordinate becomes this, x plus a, comma, f of x. Right, so quite a few people get confused by this. They think that if the graph moves to the left, i.e. in the negative x-axis direction, then we should actually be using this transformation, i.e. with the negative sign. This plus here they think should be negative. Additionally, some people don't like that the signs change in each rule. So here, this function is shifting the graph to the left and it is a plus there. But the points actually have a minus here. People don't like this change between pluses and minuses and get mixed up. So when counterintuitive and hard to remember things like this come up in maths, I always do the same thing. I write out an example, work it through and convince myself of the truth. So let's go ahead and do that. If you feel like you won't be able to remember this or it seems wrong, then let me show you how you can always persuade yourself. So again, here we have our function y is equal to f of x, where f of x is equal to x plus 2. If we want to translate this function's graph by moving it left by 3, then as we've just learned, we need to replace every value of x in the function with x plus 3. So let's go ahead and look at how this is done. Our translated function is given by y subscript left, and it is equal to f of x plus 3. Which is equal to x plus 3 plus 2. In this bracket here, there used to be x in our original function. But because we're shifting to the left, we have to replace every value of x with x plus 3. So what was just x here has become x plus 3. And this is the remainder of the original function. If you simplify this, we get x plus 5. So y subscript left is equal to x plus 5. Let's plot this on our graph that is given above here. It already has the original function's graph given in red. And in purple is this function, but translated by 3 to the left. Therefore, hopefully you can see how a translation happens algebraically down here and graphically over here. And that using the plus symbol leads to a translation that is to the left of the original function. Also note what has happened to the coordinate on the original graph. It has moved left here. So it's gone from having a coordinate of -1, 1 to -4, 1, i.e. the y coordinate has stayed the same, still 1, but the x coordinate has reduced by 3. Alright, what about moving a function's graph to the right? Again, we still have our original function, y is equal to f of x, where f of x is equal to x plus 2. And suppose we want to move our function to the right by 6 points. Well, as we've learned, we need to replace every value of x in the function with x minus 6. So here, our translated function is given by y subscript right, which is equal to f of x minus 6, which is then x minus 6 plus 2. Remember, this used to be just x in our original function, but we're replacing every value of x by x minus 6. So that's where this comes from. And this plus 2 is from the original function. This then simplifies to x minus 4. So let's plot this on our graph above. This is the graph of the original function, and this is the graph of the original function, but when it has been translated by 6 to the right. Therefore, you can hopefully see that using the minus symbol, this minus 6, we get a graph that has been translated to the right. Also note what has happened to this point here. It has moved all the way over here. So it's gone from having a coordinate of -1 and 1 to having a coordinate 5 and 1. So the y coordinate has stayed the same, but the x coordinate has increased by 6. So it's important to remember how the whole function's graph moves under a certain translation, as well as how just a single point moves under a translation. Examiners can ask you either one. They can ask you a question about a whole graph or even just a coordinate. I'll come on to some examples at the end where you just need to transform a single coordinate. But before that, we just have to go over one final type of transformation, and it is reflections. Okay, let's go over reflections. We'll look at how to reflect a function's graph in both the x and the y axis. If you have a function y is equal to f of x and you want to reflect its graph in the y-axis, this is the y-axis, you must replace all values of x in your function with minus x. That's written out here. So by replacing all values of x in your function with minus x, you're reflecting your graph in the y-axis. If this is our original graph, then when reflected in the y-axis, it becomes this graph in orange. What about the x-axis? If you have a function y is equal to f of x and you want to reflect its graph in the x-axis, you must multiply the entire function by -1, and that's written here. So again, if this graph in red is our original function, and if it were to be reflected in the x-axis, it would look like this graph in blue. Now, just as a little point, when graphs are reflected but still pass through the same point as they originally did, these are called invariant points. If you look at the red original graph and the orange graph, you'll see that they both pass through a point here on the y-axis. This is called an invariant point because the original graph and the translated graph both pass through it. Just a bit of information there. Okay, like I said earlier, it's really good to be able to think about how transformations change an entire graph as well as just a single point. So here I've put together an example of how you can calculate what transformations do to a single point, i.e. we don't actually need to know the function or plot it or draw anything really. So let's have a look at this. The function y is equal to f of x, i.e. we don't know it, passes through the point P, which has the coordinate -2, 5. Find the coordinate of P for the following functions. So let's look at the first one. Here, the translation is a move of 1 to the left and a move of 1 down. If the graph moves to the left 1, this means that the x coordinate must change. And if it's moving to the left, then the x coordinate must reduce by 1. So -2 becomes -3. If the graph is moving down by 1, then the y-coordinate must change. Because it's moving down, the y-coordinate must go down 1, so it goes from 5 to 4. So the point P goes from -2, 5 to -3, 4 under this transformation. Right, question 2. Here, the graph is moving by 2 points to the right, and it is being reflected in the x-axis. If the graph is moving 2 points to the right, then that means the x-coordinate must change and it must increase by 2. So -2 plus 2 is 0. So that's the x-coordinate. And we know that the graph is being reflected in the x-axis. So the y-coordinate must be flipped, i.e. it must become negative. So we have -5. So the coordinate used to be -2, 5, and it's now 0, -5. And finally, the last question. The function is being reflected in the y-axis as well as the x-axis, and it is moving up by 2. If the function is being reflected in the y-axis, that means the x-coordinate sign must change. So it goes from -2
to 2. The function is also being reflected in the x-axis. So the y-coordinate must change sign, so it goes from 5 to -5. But we also have that the graph is moving upwards too. So it did have a y-coordinate of -5, but it's moving up by 2, so it has a y-coordinate of -3. So it's gone from coordinate -2, 5 to 2, -3. Phew! That was a long one, but it is really high level GCSE maths. Like, these things are grade 8 and 9 probably. So well done if you're stuck in there and bared with it. I have put together some questions down here to test your knowledge. The answers to these, as well as the workings, are given on my Instagram account, so do go check that out. And yeah, thanks for watching. If you have any feedback, then please leave it in the comments on my Instagram or YouTube. I'm always looking out for new ideas or things to change up if certain things I'm doing aren't working. But anyway, thanks.